Okay, just as usual, let's try to go to New York Times this time. Let me see, how do I do this? I assume you can see my screen. Let me actually pull it down a little bit. This, I'm going to say New York Times, and I'm going to click on New York Times. The first word, wait a minute, is Trump again? All right. I'm going to use a second word, calls, C-A-L-L-S. Okay. Let me go back to my first. I should get NG-Rock running. So NG-Rock is running. So I'm going to the list. I'm going to modify EE1520 server.cpp. Oh, yes, that's the server. Okay, so we're going to change this. So Greenland is gone. I'm going to use calls. CALS. And we have to change client, which means you have to change your E1520 client program and get rid of this. Sorry. And has to change this. This is the last time. I'm going to keep it. Then I will change this to calls. So today's passcode is CALLS. Now I'm going to make it. And I'm going to run the server. Sorry, I haven't started the run server. Okay, the server is running. So I'm going to run the client. Okay, it seems to be working. That you should see this one has a cost. Okay, all right. I'm going to leave the things here. Hopefully by now you know how to do this part. If you have any question, let me know. I just want to make sure that every class you will get a chance to modify your program, to compile your program, to run your program. All right. Okay. So we spent quite a bit of time looking at operating system, looking at files with hole, looking at my break and my heal, which is very important for to learning in general the concept of how to processing the information, but also for your homework assignment number 1. Okay, so now I want to resume back to the C++ world. So this is what we did about 3 lectures ago. This is at the end of the class, I listed all the things you have learned or you should have learned about C++. So first we introduce what is the concept of C++ class and how do you provide the declaration about the class, which is in the .h file or .hpp file. Some of us using .h, some of us just using HPP. Okay, it doesn't matter. It's just how you decide your convention about how you name your file. And for the function, for the declaration, we use CPP. There are also different style, but it seems to me .cpp is a pretty commonly used style, which I will remind you with some example. And then we talk about concept of constructor. We declare member function, and one type of member function is called constructor. And constructor will be called when you use this class, which is the spec about the object, to create an object. So then we talk about, well, how can you actually create an object? And also, after you create an object, how do you call the function? So let me show you a picture. This is essentially, we talk about a illustration about what a class or what an object. So based on the class, you will create based on the class is called GPS underscore DD, which I probably should put the whole thing. But the program is under the GitHub link down there. And based on the GPS DD definition or declaration, you have an object and you have two variables, which is latitude and the longitude. And then you have a set of member function. You have a constructor and you have other member function. And then essentially when you want to access the data within the object, you need to use one of the member function. Okay, so that's why we will show you. Okay, this is the program I showed you last time. Let's see if you remember this. Let me actually get back to my code. Let me just use, by the way, I think I upload everything. Okay, I'm going to use this one. Is this the program? Yeah, this is the program. So I just want to remind you what a class looks like based on that slice. So this is a class, and the class DD has two attributes, which is latitude and longitude, and has constructor, two constructor, and have other member functions such as get latitude, get longitude, and the distance. I have other member function. I call it operator overloading, which I will start talking about this hopefully today, if not next week. And then I have a two function, which is listed here using the keyword virtual, meaning that these are member function, but there is a different type of member function called virtual function, which we will talk about that a lot much later. But right now, let's just understand when you have a class, you have a syntax to declare what is a class with a class keyword, and then you have to define attribute, constructor, and other member function, which is the class. And then if we look at the definition inside here is for each of the member function that you declare in the .h file, which now you see that I have include GPS.h. And for each of the member function, including constructor, I have an implementation. So over in the .h file, I declare I have this function. Declare means that I specify what we call function prototype. And what is a function prototype? Is the function name, the argument, number of argument, and the argument data type, and the return data type. That's called the function signature. So in the .h file, I only declare the function prototype for each of the member function and the class in general. But in the .cpp file, I actually did provide the implementation. For example, I have a member function called get latitude, and I have to say GPS underscore DD colon get latitude because this is not a regular function. If I get rid of the class, that means it's a regular function. But if I have a prefix of the class name, then this is the member function for the class GPSDD. And the function signature over here should match the whatever you declare in .h file exactly the same. Okay. For example, let me tell you, you might notice the difference is that I have a const double, which means that this number come back should be a constant number. And this number, this is a type. If you remove the const, which means that, let me get back to you here this way. if you look at the declaration over here, it also have a const. Okay, so they match exactly the same. The return type is constant double, and the definition is constant double. And the name is get latitude. So here is a get latitude, and the argument is nothing. So based on this, then the definition below of this window will match the definition that in the GPS.h. Okay, so this is what we did last time. I want to tell you one more thing before I leave this particular place. And then we have this function called, I think I call EE1520 JSON. Wait a minute, let me see. What's the file I use here? Person. Okay, sorry. I will use the person as example. So if you look at this file that we actually testing the program using something very similar to this file, which is the driver program, which is the main program. It create GPS home Woodland with 2 arguments, that's the constructor. So I create an address of home Woodland, create address of electrical engineering building 1, which is this building we're in. And then that's the GPS and also the UC Davis. And then you can see I'm calling a member function distance. Remember, distance is a member function. So this is an object. Okay, let me get back. This is a class name. And when I do a class name with a variable name, so that means I'm actually declare a object, or I create an object, GPS E building 1 Tainan. That's the creation of an object, and the variable name of the object is this portion I just highlight. And this portion after this is constructor. So because I put in 2 arguments, it will match the constructor with function signature that's going to take a 2 double or 2 floating point. Okay, so this line basically say, hey, I create an object, which is the GPS E building 1 underscore Tainan. Okay, and then how do I how do I interact with this object is I have to call one of its member. Remember, member function is whenever I want to do something with the member, with the object, I have to use the member function. So this is the way it works. This is the way to do that. So you can see that this is an object. Object is a GPS, E building 1 underscore Tainan, and object dot the member function name, distance. Okay, so object dot distance, that this means that I'm actually calling the distance member function within the object GPS E building 1, Tainan. Okay, so that's the way how you call that function. And then remember that function take 1 argument. And then let's actually look at the prototype, function prototype for if you look at distance function, it take 1 argument, which is GPSDD as an object. So that's why you see that it take 1 argument, which is the object of GPSDD. Okay, so this part match this part. And then this is the object dot. That's very interesting. Okay, wait a minute. It kills my microphone. Can you hear me? Hello? Hello? Okay. If you cannot hear me, I will just speak louder. Can you hear me in the back? Can you hear me? Okay. All right. All right. Okay, so let's try to match that GPS DD is the argument. That's why the argument is GPS TLC UC Davis. That's the data type for it's a class GPS DD. And then the return type of the function name is called distance. Okay, that match the function name. And the return type is distant one. So the return is a double. And then if you come over here, distant one was defined as a double. You can see that this match very well. Okay, so how do you, so basically this is what we did 2 or 3 lectures ago. Let me pull out my PowerPoint. By looking at this simple example, you know the basic thing. It's not too much complicated than this, by the way. This is basic. Other thing is just variation about how you can do things. So C++, declaration, constructor, how to create object, how to call a member function. So, okay, I want to show you just a little bit different about the what I will call a pointer style about doing everything like here. Okay, so I'm going to change this. I'm going to tell you what's the pointer style. Okay, so first, I can create a GPS DD star. I would say Tainan pointer. Okay, I can actually do Tainan pointer. So you can see that this is interesting, which means that I declare a variable, which is a Tainan pointer, but the data type is GPS DD star. So this means that Tainan pointer is a pointer to a particular GPS DD object. And initially, this could be set as a null. If it's a pointer, it could be null. And then I can say Tainan PTR is equal to, say, M, remember your good friend, M GPS, EE build 1 Tainan. Okay, I assign the pointer of the address of GPS E build 1, which is the same as here, into the pointer. So essentially now I have 2 references into the same object. One is using GPS E build 1 Tainan. The other one is using Tainan underscore PTR. Now this is pointing at the first byte of the GPS E building 1 object. And then when I want to call this, I'm going to write this differently. Then when I write this, I'm actually going to write it this way. I'm going to write Tainan PTR to the distance. Okay, you see, I just have 2 different styles about how I can call a member function. I can either use the object dot distance, or I can use the pointer version, Tainan PTR, to the distance. If you learned about struct, how to use a struct using the pointer style, this is exactly like how you will use a struct using pointer style. Okay, so that's just a variation. So in fact, the principle, the concept is exactly the same. How do you declare a class? How do you create an object? How do you access the member function? It just have 2 different syntactic style. One is using regular object, one is using pointer style. Okay, it's your choice, but as a C programmer, we kind of learn both representation. Okay. Okay, any question at this moment? What I'm doing here is review plus a little bit variation. Okay, so now let's get back to this. So this is what you did. Okay, so now I want to do one thing, which is interesting. I want you to see here. So far, we have been looking at this object-oriented paradigm, and we focus on the GPS class. And then we have I don't know if you noticed that, but this is the important difference. It's 2 different paths to go into the object-oriented programming. So one is a pass is a C++ pass. I just talked about like 5 seconds ago. But the other pass, which we have been telling you, is the JSON style. So I have this two. They're essentially the same. Okay. First, I'm just telling you, okay, you have to define a C++ class. You have to define the member function, which I call the method or member function, and including the constructor. And then you have to create an object, right? And then you have the object. But the other way is I'm just using JSON. I'm just using JSON to describe an object. And this is my representation. Oh, sorry. This is my representation about a JSON object. It's a key value pair. If you think about this, what do you think the difference between this red representation over here versus the GPS.h you just see? They're essentially the same. They're essentially except the JSON object, it's the data portion only, not the member function, not the constructor, but instead it just tells you what it is. What is an object? What is a GPS? It's latitude and longitude. It's really matter about these two variable. By the way, I haven't told you this, but you could represent function name, the member function name, also within JSON. There's a way to do that. I'm not going to get into that difficulty. But in C++, then essentially you have the same structure with this two variable, and you add a few things. And those things you add is for you to access the object. Okay, so in other words, so far in this class, we represent two different data representation for the concept called object. One is C++, one is called JSON. Okay, so let me actually try to open the floor for you to discuss a little bit among ourselves. Which way do you think is better? So I'm talking about object-oriented programming. Of course, I have to represent the object, right? So what's the difference? I probably shouldn't say which way is better. We know eventually we need both. But which way is easier for you to describe an object? Is it JSON way or C++ way? This is a bit controversial, okay? But if you're a C++ programmer, you probably will say, oh, there's no big difference because I already know C++. I know how to actually specify a class. So using a C++ is very easy for me to describe an object. But for a average person, that JSON is much easier because JSON is readable. You directly focus on object. You don't think about the structure. You don't think about the class, but you directly think about what's the data, what the format looks like. So in terms of for you to try to understand, if the problem is well-defined, then C++ is probably okay. But if the problem is somewhat not sure, for example, GPS location, so far we just say latitude and longitude, but what happens if I want extra information, such as a label of this particular location? Then essentially you might need something else, such as, let me go there, you might need to introduce another variable I call a label. And under the label, it's a string. I would say NCKU EE building 1. I mean, that's very natural. Oh, label, I forgot an L for this label. Okay, you can think about that sometime. This format is very easy. I don't need a compiler for me to start doing the object-oriented design. Because in object-oriented design or object-oriented thinking, the important things in our mind is a bunch of objects. And then we try to use the easiest way that we can use to actually define what the object looks like. And once we have this, then it's fairly easy for you to either manually or even automatically to translate from the JSON representation to C++ code. If you think about that, this is very easy because I take a look at this, immediately I know in my C++ class, I need 3 attributes. Number 1 is called latitude. It's a double or it's a floating point. I probably would choose double. And then there is another attribute called longitude, and there is another attribute called label, which is a string. Okay, so I'm actually using the basic type of JSON representation. I can immediately from this object instance, this is the object instance, I can actually create a class, a C++ class, or by the way, I can use this to create a Java class, or I can use this to create a Python type of object representation as well. So with JSON, you can actually convert to any object-oriented language you like. Okay, okay. This is a difference. I want you to by the way, the way I teach, I have been teaching C++, is somewhat different from most of other instructor. Not just in Taiwan, but in US as well. Is that I usually started to introduce C++ via JSON. So I'm using JSON as a way to understand C++, while most of the instructors just directly teach object-oriented based on C++ itself, okay? So I'm not saying which way is better, but this is just an alternative way for us to understand. Okay, so now this is object-oriented programming. So based on this understanding, so in your picture, I want to think about when you do object-oriented programming, you actually have 2 different styles. One is a data representation, probably based on JSON, and the other, which is a C++ specification. So this is lead to my next slide, and then we'll continue to do this. Is that in object-oriented programming, we're focusing on objects. We're focusing on objects. So if you're not doing object-oriented programming, usually you try to solving a specific problem, which specific problem means that you know exactly what's the input data. You know exactly what's the algorithm to process data to generate, you know exactly what the output of the data. So input is given, not just given your input, but given the format of the input. And then you have a well-defined problem. And then you have a well-defined expected output. That's typical, for example, travel salesman problem or bubble sort, which I hope you remember. You should have learned bubble sorting of the data in the Introduction to Computer Science 1. So that's a typical way of solving a problem. But object-oriented is not. Object-oriented, usually you focus on the object. And why do you focus on the object? Because you want to think about what's the problem around this object. So instead of specify the problem, you try to describe the object, and then you try to find the problem to solve. I mean, let me give you an example, robotics. If you want to have a robotics go around this particular classroom, then what you need to focus is what are the objects in this room. There are computer, there are student, there are instructor, there's table. And then from here, you see a lot of backpack in this. And then of course it has chocolate, right? So this is basically the object that's in this room. And then we have a projector, we have a lighting, we have all kinds of objects. So to talk about robotics, it's really important to focus on how do I describe this room as a bunch of objects and what are the property attribute of each of the object. And then you have the robotics. And then you can just tell the robotics, you say, hey, I want you to walk from point A to point B, and then try to avoid hitting any of the backpack that in this particular aisle. Okay, so essentially you think about this has become a general that I can actually tell the robotics to do this based on this complex environment. But I can also tell, hey, now this is not a general walking robotics, it's the cleaning robotics. I want you to get rid of all the backpack that's actually in this aisle. Okay, so as long as I have a way to describe this room, I can actually have a multiple type of application that's actually based on how this program, how this general application is going to interact with all the object that's actually in this room. Okay, so in other words, in object-oriented programming, we're not focused on solving a specific problem. Instead, we focus on, well, what kind of objects that we need to have. And based on that, then we can specify those objects using JSON or using C++, either way. And then we can solve all the problem that's related to this object. Okay, so that's a little bit different. So by the way, this is a little bit conceptual, but it's important for you to understand the difference between OOP and the traditional programming. Okay, any question? I forgot my chocolate again. Okay, none of you remind me. Okay, it's in my office. I'm going to get in the break. Okay. All right. So now I'm actually going to a bit more flow. So we already see there was a class called GPSDD. And in this class, I'm going to introduce another class called class person. So once I introduce this class, we understand the basic, how do you define a class, how do you create an object. Then we're going to move to the next topic, which is called operator overloading. Okay, so you can see that I have a class DD, I have a class person. This is a function I have to declare. And usually what we did is that you have to create the class GPS.h, and then of course you have a person.h as well. And then you have to provide it, and then you have the GPS.cpp, and then you have a person. And then you have a test program, which is, I show you the other code, which is, I forgot what I call that. I probably call it EE1520 something, which is the main program, which will create the object. So I have at least a bunch of the classes, which is represented by .h and .cpp. And then I have a driver program, which is essentially the main program is the one who is going to decide what's the application I need to have for those objects. Oh, by the way, there is a convention I should mention. It's highly recommended that you put one class in one single file. Like a GPSDD, I put it in gps.cpp. You could put multiple classes in a single .h or .cpp file. It might create some problem in practice, but later we'll get to that. Okay, so you have the GPS.h, GPS.cpp, and then you have a main program, and then you will use the compiler G++ to compile this program from GPS.cpp, and you're going to generate the .o file, object file. Okay, so the first slide I show you G++ minus std C++ 17 with a minus C flag. This means this is doing compiling. And this line is going to generate the object file. So you're compiling from the source file to the object file. By the way, some of you made the mistake is that when you try to execute the program, you actually type in, for example, EE1520 participation.cpp. So .cpp is the original source code. It cannot be executed. It's not executable. So you have to generate the object file using the make file, using whatever you want to do. And then eventually you have to link things together to generate the executable. And then you have to run that executable. So you have to know the convention is whether the file is ended, the suffix is .cpp or .h, or there's nothing, or a.l, those kind of files. They have their different attribute to do that. Okay, so this is essentially what we did with the object-oriented programming, that you create a bunch of classes. But on the other hand, before you create all the class, you should actually start thinking about what kind of object you want to create or what kind of classes you want to define using JSON. That's my preference way to do that, because I can actually immediately specify what my object should look like. And then I can, based on that JSON, I can create the class GPSDD and class person. Okay, any question regarding this picture? Okay, the other thing I forgot to mention is that in object-oriented programming, is very, very common that you're going to change. You're going to make change because at the beginning, when we understand this complex world, we probably don't know exactly what we want to create in terms of the class. So, for example, I showed you earlier. In this example, when I show you the first version of the GPS DD, it has only two attributes, which is the latitude and longitude. But in reality, in the development process, it's very easy for you to introduce extra feature, extra attribute, which you realize that your application need that, okay? For example, when I describe the object, initially, I probably don't care about the color of the backpack. I say, it's only your backpack, I'm going to avoid it. So the thing is that now we're going to say, hey, wait a minute, the object backpack need to have an attribute called color because some of the color of the back, the robot is going to do somewhat different. So it's very common in object-oriented programming. You're not thinking about solving the problem at one shot. In fact, most likely you start off with something which is maybe only partially useful, but then after you develop your program, you realize, oh, you need the extra attribute, and then you will add it to that. Okay, and which means you're going to modify JSON, or you're going to even modify the C++ declaration in order to get to the object that you want, okay? Okay, so let me show you the second object. It's called person object. I do have a person object, looks like this. This is a person object which describes the first name, last name, and a bunch of other things. But I'm actually going to do a different kind of person object that's actually already uploaded in GitHub. I will call it ECS. No, I don't want to do this. I want to say person. What did I do? Sorry. I'm declaring another class called GPS, not GPS, person.h. And let's take a look at this person.h, what I have. I only gave three attributes. One is called VSID, one is called name, and one is called home. So, I mean, of course, this is a very simplified way of representing a person object. So what I have here is the VSID is equivalent to your national ID number, your 身份证 number, okay? And then your name is your name. And then your GPSDD is your home address, right? I can actually do that. So once I declare this, I actually see that the only perspective I care about a person at this moment, and my first design, is just their some form of the ID and your name and your home address, okay? And then I can actually try to change this. I can change to another one. I can say current location. Okay, I actually declare another variable. So home is your home address, so I can mail it to you, a package, or whatever things I want to mail it to contact you. But this person might move around, right? I mean, my home is about 5 minutes walk from this location, but now I'm actually in electrical engineering building. Okay, so now I have my current location. That's my attribute to do that. So you can see that now I actually introduced two concepts. First, we can declare another variable called person. By the way, you can think about that for almost all the application. that you probably need to have a declaration about person, because the environment that we're dealing with, robotics, any kind of social gathering, any kind of vacation, it must have a person. That's why your Google Map is always associated with a user ID. A user ID is representing a person. So, and how do I actually include that? You can see here, I actually did is I have an attribute. So previously in GPS DD, the attribute is a what? Is a basic type, which is the double. But now you can see that a person has attribute itself is an object. Okay, and obviously here I have two choices. The choice I made here is I make the one of the attribute is a how do I say that? Oh, I have to click it. It's a pointer to a GPS object, but I could have done this. I could have changed to be only this. In this, meaning that the attribute is a object instead of it's a pointer to an object. Okay, or it could be a reference to an object. I mean, later I will tell you the difference between, I have actually three ways to specify. This is kind of make things a little bit complicated. This is something which I don't appreciate that much. I can actually have a three different way of describing the same thing. This is a pointer version. This is a reference object reference, and this is a object copy. Okay, there are three different ways I can specify an attribute or an object. At this moment, don't worry about object reference. This is kind of for C programmer. This is a bit confusing because adding an M sign. I will talk about that in greater detail much later. But for C programmer, you know, at least there is a pointer representation. There's a regular representation looks like this. Which way is better? It depends, depending on what you like to do and whether, I mean, the reason I use a pointer or the copy is that if I use pointer, then I allow somebody outside of this object to modify the value of home. So in other words, I would say this might be something better. In other words, my home address is not changed that much. So my home address is a copy. It's not a reference. But my current location might change all the time. For example, I might allow a bus which share the same location with me, or my phone has a location. This location is shareable between multiple objects, and one of them change, then the rest of them will change as well. Okay, I'm going to stop here. We will continue to look at the person object. Okay, I'm going to still turn on the participation. Please submit. Today's keyword is cost. Okay, all right, see you later.